Hello, thank you for watching this video. I hope that you find it helpful. This tutorial is taking you through one of the ALEKS topics where ALEKS is asking us to rank either oxidizing power or reducing power based on standard reduction potentials. I have two examples in this video and we'll go through both of them. But first I want to give you a couple of basics that help you understand some of the concepts that are going on here. So all of this is referring to standard reduction half reactions, and we can write those in a general form as an oxidizing agent that I'll call OA, picking up some electrons. I'll just make this one electron for this example, and turning that into a reducing agent, RA. So OA stands for oxidizing agent, and RA stands for reducing agent. Now we should recall that the E0 value attached to any reduction is in some sense a measure of the strength of that reduction. We should also recall, or I want to point out, that there's a reciprocity between the oxidizing agent and the reducing agent. So the stronger an oxidizing agent is, it's partnered with a weaker reducing agent. So the way you get to a very positive and large value of E0 is by having a good oxidizing agent and a fairly poor reducing agent. So let me summarize a little bit here. So if we have a more positive value of E0, comparatively speaking, that means a couple of things. One is that we have a better oxidizing agent and we have a worse reducing agent. If we have another half reaction that has a less positive E0, or another way to say that is a more negative E0, then that implies that we have a worse oxidizing agent and a better reducing agent. Okay. Now let me give you a couple of examples here. I have written out all the half reactions for the examples that ALEKS gives us, and I've even looked up E0 values. Let me put a couple of E0 values in here for you. So the E0 value for aluminum is negative 1.66 volts. In contrast to that, the E0 value for silver is positive 0.8 volts. Okay, so now what this tells me is that in silver, the silver plus really wants to pick up an electron and become silver solid. And comparatively speaking, the silver solid has less interest in giving up an electron to become silver plus. Okay, so in other words, the silver plus here is going to be a fairly good oxidizing agent, and the silver solid is not going to be as good as a reducing agent. If we look at aluminum, aluminum 3 plus can pick up 3 electrons and become an aluminum solid, and the E0 is negative 1.66. So that tells me that, especially compared to the silver, that this reaction really does not want to happen very much, that there's not much motivation for aluminum 3 plus picking up 3 electrons and becoming silver or aluminum solid. On the other hand, we can think of this negative number as telling us that aluminum solid really is fairly interested in giving up 3 electrons and becoming aluminum 3 plus. Okay, so the more positive something is, the better the oxidation agent, the more likely the reaction is to go. The more negative it is, the worse the oxidation agent is, the more likely the reverse reaction is to go, which means that we'll have a better reducing agent. So in this problem, we're asked to rank things. Okay, so in terms of the reduction potentials, if we think about ranking things from most positive to most negative, then we can put things in order of decreasing, reducing, we'll call it reducing power, to use the phrase that Alex does. Okay, so decreasing, I'm sorry, oxidizing power. Getting that mixed up. My apologies. So the most positive E0 values will have the best oxidizing agents. The most negative will have the most negative will have the worst oxidizing agents. If we rank our reactions from most negative E0 to most positive, then that is in order of decreasing, reducing power. Okay, so the best reducing agents are going to be associated with the most negative voltages. The best oxidizing agents will be associated with the most positive reduction potentials. Okay, so let's work through the example problems. And so I've given you two of the numbers that you need. The other two are negative 0.76 for the zinc and negative 2.87 for the calcium. Okay, so negative 2.87 is really really a big negative number, and that tells us that calcium really does want to lose 2 electrons and become calcium 2 plus. But on the other hand, the calcium 2 plus really does not have all that much interest in picking up 2 electrons and becoming calcium solid. This we might kind of expect based on the notion that metals lose electrons, and calcium will tend to form a 2 positive ion in order to get a noble-like structure. So Alex wants us to rank all of these species in terms of their reducing power, and it wants us to go 1 being the highest to 4 being the lowest. So the highest reducing power, meaning the best reducing agent, to the worst reducing agent. Okay. Okay, so if we want to go highest to lowest in terms of reducing power, then we want to go most negative to most positive in terms of the E0s. So most negative to most positive. So we're going to put our calcium as the most negative. That's the first one. Then the aluminum, then the zinc, and then the silver. So 1, 4, 3, 2. Down at the bottom, let me give you those numbers. So negative 0.76 for zinc, negative 2.71 for sodium, negative 2.37 for magnesium, and negative 1.66 for aluminum. And these are all in moles. Okay, so here we're wanting to rank things in terms of oxidizing power. So we're wanting to say number 1 is the most positive E0 value, and number 4 is going to be the most negative E0 value. So to rank in terms of decreasing oxidizing power, we'll go from most positive to most negative. So 1 is highest oxidizing power, going to 4 lowest. And we can think of that as best oxidizing agent going to worst oxidizing agent. All right. So when we look at these numbers, the most positive value on here is actually zinc. So we can say that zinc 2 plus is going to be the best oxidizing agent in that bunch. And then in terms of going from most positive to most negative, the aluminum is next, so that's 2. Then the magnesium, so that's 3. And then the sodium, so that's 4. So 1, 4, 3, 2. Hey, what do you know? The order is the same in the top and the bottom. That's really kind of interesting. I wonder if that's true for all of the ALEX things. I wouldn't bet on it. Okay, thank you very much for watching. I hope that you find this video helpful.